Blessed day everyone. Today we are going to discuss about the different chapters of the engineering data analysis. First, the chapter 7, the statistical interval.
Second, Chapter 8, Test of a Hypothesis.
Chapter 9, statistical interference of two sample.
Chapter 10, Simple Linear Regression and Correlation.
And lastly, chapter 12, design analysis of single factor experiments. We are the reporters. I'm Jezreel Josh G. Passion,
And I'm Jericho Embrañeses.
your reporters.
First, we will discuss about Chapter 7, Statistical Interval. After this chapter, it will help to determine the represent an uncertainty that exists in the data because we work with samples that are obtained from a larger population or process. The subtopic for this chapter is confidence interval for a single sample. Confidence interval is the range of values that you expect your estimate to fall between a certain percentage of the time if you run your experiments again or again, re-sample the population in the same way. Before we solve the confidence interval for a problem, we should determine what confidence level we want to use. Confidence level it corresponds to the expected proportion of intervals that will contain the parameter if many confidence intervals are constructed of the same sample size from the same population. But there are common confidence level that always used for a certain problem, which are 90%, 95%, and 99%. 90% is equivalent to 1.645 critical value, and for 95%, 1.96, and lastly for 99% and the higher confidence level we want to get is 2.576. This value came from our understanding of the standard normal distribution. Further illustration, let's use diagram. This diagram shows the first formulated formula, which is P times negative Z alpha over 2 less than Z alpha over 2 equal 1 minus alpha. We all know that Z is equivalent to x bar minus mu sigma over square root of n. Now, by multiplying through sigma square root of n, subtract from each from x bar, and multiplying through negative 1, finally we will have the formula for confidence interval. Thus, confidence interval is x bar plus minus e with e z alpha over 2 times sigma over square root of sample size. But there are different types to determine confidence interval. First, confidence interval about the mean mu, the population standard deviation sigma is known. It is computed as EZ as a critical value from the standard normal table associated with alpha, sigma over square root of n. Now let's have an example. A random sample of 65 Hollywood movies had a mean length of 115.2 minutes. Suppose the population standard deviation is 11.7 minutes. Construct a 95% confidence level. As this, we all know that our formula to determine the confidence interval is E is equal to Z as a critical value times sigma over square root of n. Like I said, 95% is equivalent to 1.96 as a critical value. Our sigma is 11.7 and our sample size is 65 Hollywood. Now, E is equal to 2.844. Now, to compute the confidence interval, subtract and add the x bar and E. We all know that our x bar is 115.2 and our e is 2.844. Now, if we subtract it, we will have 112.356 and if we add it, we will have 118.044. And finally, we have the we concluded that the 95% confidence interval that the population mean length of Hollywood movies is between 112.356 and 118.044 minutes. And for the second one, confidence interval about the mean mu when the population standard is sigma is unknown. Which is, if you draw a simple random sample of size from a population with mean mu and unknown population standard deviation sigma and calculated the t-score, now we will have t is equivalent to, sorry for the error of typing, x is equivalent to x bar minus mu over s over square root of n. Then the t-score follows a t-distribution with n-1 degrees of freedom. The t-score has the same interpretation as the z-score. It means how far in the standard deviation until x bar is from its mean mu. For each sample size n, there is different students t-distribution. And now, because of these changes, our critical value will be by using the t-table. And we will have a final formula for this problem. E is equivalent to t critical value times s over square root of n. I will show you the t-table. A sample size is always b minus 1. And up in this upper table, we will have the percentage of our critical value. Now, let's have an example for confidence interval about the mean mu when the population standard deviation sigma is unknown. In order to estimate the population means EMS response time from notification to arrival at the crash scene in urban areas, a random sample 20 crashes results in a mean of 5.25 minute standard deviation of 2.78 minutes. Construct a 95% confidence interval. Now, our critical value is 1.729. Our final formula is E is equal to the critical value times S over square root of N. Now, as we go on, we will have finally concluded our E is equal to 1.075. Now, let's add and subtract our x bar and e. When we subtract our x bar and e, we will get 4.175, and when we will add it, we will have 6.325. Now, we concluded that the 90% confidence interval that the population mean EMS response time is between 4.175 and 6.325 minutes. Lastly, confidence interval about the population proportion. Now, we all know that P is equal to X over N. It's the sample proportion. And now, N times P times 1 minus P is greater than or equal to 10. Now, we will have the final formula for this topic. E is equal to Z alpha over 2 square root of P times 1 minus P over N. Now, let's have an example. A botanist has produced a new variety of hybrid soybean that is better able to withstand drought. She wants to construct a 95% confidence interval about the germination rate or germination. She randomly selected 500 seeds and found that 421 have germinated. Now our sample proportional is x over n. Rx is 421 and Rn is 500. Now our sample proportion is 0.842. Next, our formula for this is E is equal to Z alpha over 2 times square root of E times 1 minus E over N. Now finally, we will get E is equal to 0.032. Now we will subtract and add the sample proportion and E. If we subtract, we will get 0.81 and when we will add, we will get 0.874. So that we concluded that the 95% confidence interval for the germination rate is between 0.81 and 0.847. That's all for this chapter.